Now we will learn about resolution of a vector. Resolution of a vector into components. So that means it is a reverse of addition of vectors. Only the reverse process of adding vectors. Okay, so we have added two vectors in this way. Say this car, the car moves from here to here, so the displacement vectors are this, this and this, so resultant is this. Now suppose I ask a question that car goes from here to here. A car goes from here to here, so it started here, here to here, see. So that means you have a vector A. Now, so how many components does this vector have? That means in how many ways you can get this vector A. That means how many vectors you can add to get this A. So they are infinite vectors, right? Infinite. So there are infinite component vectors, right? Infinite component vectors. That means in infinite ways the car can reach from here to here. Say it can go like this, here and then here. So it has two components now. Or it can go like this, this, this and this. So it has three components. Or it can go here, if it has wings, it can go here and then go here, come down and go here. So it has 1, 2, 3, 4, 5 or whatever. So it can have infinite components. Or you can find a car there, there, there and there, right? So it can have infinite component vectors. Okay, so you can write, say in this way. So vector A1, A2, A3. So you can write A as sum of these vectors, A1 plus A2 plus A3, this way. Okay. Now, what is the use of having components of a vectors? That is the thing, na? So you know the purpose to add vectors, okay, that we know. But what is the purpose to split up a vector into its components? Obviously there is some purpose that we will know now. Okay. Now, generally speaking, the component of a vector on a line is defined like this. Say that is a line, this is an axis. This is an axis and there is a vector. Say through this. This is a vector A and this is theta. Now the component of vector A along the axis is given by A cos theta. That means it's not a component vector, right? Generally speaking, the component of a vector is not a vector. It is the projection of a vector, right? We sometimes we say about component vectors, but in general component of a vector is not a vector. So that's A cos theta, right? Okay, so component of a vector in this direction of this axis is equal to A cos theta. Okay. Now if it were like this, suppose this is an axis, and you have a vector like this, A. This is 90 degree. So here component of A on the axis, now component of A on the axis in this case, right, component of A, vector A on the axis is equal to 0. A cos 90 is 0. Okay. Component of vector on an axis can be negative also. If this is an obtuse angle, then obviously it is negative, right? Okay. Suppose uh, this, suppose you have a coordinate system. I am drawing vectors in a certain plane only. So this is the x axis and y axis, and this is a vector can lie here. Vector A. Now suppose A is equal to 20 units, and say this angle happens to be 30 degree. Okay. Now the component of vector A along x axis and the component of A along the y axis, we'll find that out. So along x axis, the component of a vector is, so you draw the perpendicular on the x axis. This is it, right? So that's A cos 30, and draw perpendicular, that is projection, on the y axis. So this is equal to A sin 30. So we call component of A along x axis, generally we denote it by A suffix x, and component of A along y axis A suffix y. So that's equal to see 20 cos 30 means how much? 20 into root 3 by 2. So that's 10 root 3, and that is 10. Okay. Now what is the use of the components at all? Right. Now here you see, suppose if you add two vectors like this, suppose we add three vectors. See, suppose we add three vectors. I'll show it by triangle law. Sorry, three vectors means polygon law. So that is x axis, y axis. So you are adding vector A, vector B, and vector C. Right? It's joined like this. Wherever they were, these vectors, I have joined it like this to apply polygon law. So the resultant vector is this. This is the resultant vector R. Okay. Now let's resolve this vector into components. That means let's find the components of the vectors A, B, C and R in the direction of x and y axis. Okay. So that, what is the x component of A? Ax, this one, Ax, and the y component of A, this projection, or it's this only, that's Ay, this length, and component of B on x axis, this is equal to Bx, and component of B on the y axis, that's By, right? Component of C in the x and y axis, component of C in x axis, this the projection, that is Cx, and component of C along y axis, see y axis, but means you draw this line projection, it is same as having this line, this length is same as this length, right? So that's Cy. Now what is the component of R in the x direction? I mean along the x direction. Component of R along the x direction is Rx. Component of R along y direction is Ry. Okay. So you see, Rx is equal to Ry is equal to C. Rx is Ax plus Bx plus Cx. Ry is Ay plus By plus Cy. Okay. So this is the thing, we have first resolved the vectors. Resolve the vectors, that means this resolution of a vector, as we know. first resolve vector into its rectangular components. Rectangular components means the components along x and y axis, along x and y axis. Now we are talking about 2D vector only here, right? For the time being we are talking about 2D vectors. So resolve the vector into its components, and then the x component for resultant vector, the x component is summation of x components of vectors added, and y component is also summation of y components of the vectors to be added, right? Now suppose we so here first we have to resolve a vector into its components. Now we'll go into further details of this. Now we'll learn about unit vectors now, right? So what is a unit vector? Unit vector is a vector of magnitude unity, right? Now it is dimensionless. That means, say you have a certain vector A. Suppose this A happens to be a displacement vector. So the unit vector in the direction of A, unit vector along A is given by A cap, right? So that's it, A cap. Now if you write mod of A cap, you have to write 1 here. Suppose A happens to be a displacement vector, then mod of A cap is not 1 meter. If A has dimensions of length, the magnitude of A vector is 10 meter, magnitude of A cap is not 1 meter, it's 1. So unit vector along A is given by A cap. Now you get A vector like this, its magnitude of A multiplied by unit vector in its direction. This is the thing, this is how unit vector is defined, or you can define it in this way: unit vector in direction of A is vector A divided by magnitude of A. See, the dimensions will cancel, so it has length here and length here, so it will cancel. Okay, now this unit vector concept and resolution of vectors are very much related. That is why while studying we have to study these two together, resolution of vector and unit vector, this concept. It will be clear in a few minutes, I hope. Okay, now suppose for the time being I am talking about the x and y axis only, that is two-dimensional. Now suppose this is x, y axis, right? Now we define unit coordinate vectors. Are unit vectors along x, y and z directions. that means say along x axis it is given as I cap, along y axis it is written as j cap, and along z axis it is written as k cap. Okay, so unit vector along x is I cap, unit vector along y is j cap, unit vector along z is k cap. This is how they are denoted. So in some books you will find x cap, y cap and z cap, or they are also called x roof, y roof and z roof. So here I will denote by I cap, j cap and k cap. Okay, so suppose there is a vector here A. Now this vector having magnitude of 20 meter A. So how do you write A as a vector? I have to write it like this: 20 meter into I cap, right? Or I can write here 20 I cap meter. Why? Remember the definition of unit vector. This is how it is. Say any vector A is its magnitude multiplied by unit vector in its direction. Okay. Now suppose you have a vector here, that's a vector B. Now this happens to be 20 meter. Okay, so how will you express B as a vector? See, B as a vector is, its magnitude is 20 meter and unit vector in this direction. See, unit vector in this direction is I cap, unit vector in this direction is minus I cap. So into minus I cap, right? So you can write it like this: minus 20 I cap meter. Okay. Now say x, y. Okay. Now suppose you have a vector like this. Say this I am taking as a force vector, say 20 Newton. Say vector F. So how do you denote? How do you write it as a vector F equal to 20 j cap Newton, right? Now if you have a vector like this, say 30 Newton, say force F dash. So how do you express it as a vector? F dash equal to minus 30 j cap Newton. The same thing works for the z axis, right? Z k cap and minus k cap. Okay. Now this one, say you have a vector here. Suppose I'm starting it here only. Suppose this is a vector C. Vector C, its magnitude is 20 meter. This is 30 degree. Now how do you express C in terms of unit coordinate vectors? That means I cap and j cap, unit coordinate vectors. Okay, so here it is. We'll go for resolution of the vector. That means you have to express this vector as sum of two vectors, one parallel to x, one parallel to y. So now we will resolve it into components. See, this one draw perpendicular. Now this is the x component. How much it is? 20 cos 30. And this is the y component, or this is the y component, same thing. Okay, so this length is how much? this length is 10 root 3. Okay, so this is 10 root 3. Okay, and this length is, or this length is 10. Okay, so this, you make it a vector by multiplying I cap, and this make it a vector by multiplying j cap. So in terms of I cap and j cap, C can be written as this: 10 root 3 I cap plus 10 j cap. As it's in meter, you write meter outside. So this is how you can express a vector in terms of the unit coordinate vectors. This is resolution of a vector into its x and y components, right? So that is most important thing, resolution of a vector into its rectangular components. Rectangular components, that is components at 90 degree. Components at 90 degree. Now we are talking about the 2D thing, so don't worry about the z axis right now. Okay, so suppose this is a vector like this, right here. So that's vector A. Now suppose this angle happens to be 60 degree, and this is say 10 meter. Okay, so how to express vector A in terms of unit coordinate vectors I cap and j cap? Okay, so here vector A, see, what is the x component of A? X component of vector A is this. See the x axis direction is here, drawing perpendicular, this length is 5 and this length is 5 root 3. See, the x component of A is -5 and the y component of A is plus 5 root 3. Okay, if you have an axis here, if the component lies here, then it's negative. By the way, we have to express it in terms of I cap and j cap. Then you have to write it like this: A is equal to, so it's sum of which two vectors? A is sum of, we resolving into two vectors along x and y. This has to be along -x and this has to be along +y. This is how you resolve this vector into two x and y components. It should be in direction of -x. Okay, so that's A equal to -5 I cap plus 5 root 3 j cap, and it's meter.